Okay, so now we're going to start today's lab. The way you do it, I did lab last night. So the way you do it is to open the browser. So I'm going to share my screen. You print out the worksheet. You print out the 4-page worksheet. You can use pencil or pen as long as your writing is clear. Put that on your desk. You have the worksheet that you're working on, and then you, I'm going to share my screen. You open the browser. On the browser, I don't need that one. On the browser, you are going to have today's lab. It's this link, waves. And you have to read, for example, 1A, what is required. What is required in 1A, and then write the answers on your worksheet. But there is another tab that you have to open. So this is the simulation. Right click and say open link in new tab. So you need 2 tabs on your browser. One is this page, the waves. This is about how you do the activities. And the other one is the simulation. And then you have to have worksheet in front of you. Today's lab, I'm going to do it. I'm not going to finish all the intro in one go. I want you to work on the worksheet together, at least for the first 2 pages, most, so that we can, at least get something done in class. Okay? So you should get if you have printed out the worksheet, that's best. Otherwise, get a blank sheet of paper and a pen or pencil. Let's work together. All right. So that's the simulation. You press the start button. And we're going to do the water waves first. Okay. You need to look at how it's fairly easy. To do the wave, you click this green button. And this water drops comes down at the regular pace, and that created waves in the water. These are water. You can take a side view. Maybe it's easier to see it. Okay. See, the waves are created, and then it's travels on the water, surface of the water. I'm going to go back to the top view. So there are a couple of things related to the wave. Basically, almost all waves have these terms. One thing is called frequency. That means how many waves are happening per second. Okay, if you're standing on one place and count how many, troughs and peaks pass by you in each second, that's the frequency. Or you can measure, same thing. You can stand here and measure, okay, a peak passed by me, and later on another peak passed by me. The 2 successive peaks, they separated by 1 period. So period and frequency both describe how quick the waves are happening. Period, that's our first equation on our worksheet. It says frequency and the period, they're inverse to each other. If you know the period say is 1 second. That means I see 1 peak each second. That means there is 1 wave in each second, so the frequency is also 1. If I see 2 waves pass by me in 1 second, then the period is only half a second. But because I see 2 peaks pass by me, then the frequency is 2 hertz. Hertz, the unit hertz is 1 over a second. 1 hertz equals to 1 over 1 second. Okay, so that's the unit of hertz. they're the same thing. Another thing is the wavelength. Wavelength is, maybe it's easier to see the side view, is the distance. So you should, in reality, in the real world, you can take a picture, but in this simulation, you can just pause and measure the distance between, say, peak to the next peak. We have a ruler, so we can measure that. That's the wavelength. Okay, and also the amplitude. Amplitude are how, let's play it, and we can change the amplitude. If amplitude is small, you see there's not much up and down motion. If the amplitude is big, then it goes up and down by a lot. So that's the amplitude, is how strong the wave is, how much up and down it goes. All right, so let's return into the default setting, that is press this orange button. So we start with the default. Let's read what we need to do. We're ready to do the worksheet now. Leave all settings as default. Use your cell phone. So get your cell phone. We need your cell phone now, which is turn on open your alarm clock or whatever the clock, and get the stopwatch ready. Stopwatch. So, okay. So you need to get your stopwatch ready on your cell phone. And what we're going to do is to measure the period first using the stopwatch. Of course, when you're doing that, you cannot pause your simulation. If you pause, I will start a wave. Okay, I will start a wave. If you pause, the time still, if you pause the screen, your stopwatch still goes. So the period will be wrong. So you cannot use the pause button now. What you have to do is, you see one, we're going to time the period. That is the time interval between like two peaks, or we can use the period of the time interval of this water drop appears. Is they all have the same period. Okay. Okay, you can time the appearance of the water drop, or you can time, say, the peak past 1 point. I will time when the water drop appears. So when I see a whole water drop, I will click start. And when I see the next water drop, I will hit stop on my stopwatch. Why don't you try it too? Okay, let's all try to measure one period. So start, stop. Do we have a number? If you have a number, you can type it in the chat. Or you can try it again, okay? Try it again with your cell phone. Good. Or next you can try to see a point, a peak past the point. So just leave your mouse, let's say like that. When the brightest spot pass you, you press start. When the next brightest point pass you, you press stop. You will see the number, it's fine, because now we have a reaction time. We have, to judge when I see the water drop, we are going to have different numbers. Yeah, all those numbers are good, except 1.36 is a bit too short. But I've got 1.5. Just now I actually got 1.50, but I've got 1.65 before. So anything between 1.5 and 1.7 are fine. So what you do is you write, that's your first number on your worksheet. Again, you may use pencil. You you should have 3 sig figs. All of our work stopwatch will measure to 1/100th of a second. Take the inverse of that. Frequency is 1 over this number. That will give us the frequency. And you can write that down. The unit will be hertz. I say you for this one, do your calculation. There is a hint. When you read the numbers, you read everything displayed on your stopwatch or in the simulation. But when you do a calculation, this is the result. So use sig fig rules. Okay, for example, if you get 3 sig figs for the period, you get 3 sig figs for the frequency. Now let's try to do it again in this. We're still in 1A. Read this. Next is we're going to try 10 periods. Then measure the time for 10 periods with your cell phone. And then you need to take the number divided by 10 to get a period. Because we know when we calculate one period, we have lots of uncertainty, right? So the numbers are really different. So we are going to try 10. This time, you start when you see the first work, you press start when you see the first water drop, and then you count 10 and then stop. When you count 10, stop. So I'm going to show you. So when I see the first drop, start, 1, 2, 3, like that. And when you count 10, you stop on your stopwatch, okay? You press start, but that's not 1, that's start or 0. And then after you see the next water drop, that's 1. Okay, I'll give you some time, like a minute to measure, half a minute is good, to measure the time for 10 periods, okay? All right, anybody? Yeah, good try. Okay. No, this one, so far I haven't seen a good number yet. So let's give it a second try, okay? Okay, there is one number that's close. Okay, you can, if you find it's too hard to count the water drop, you can do the other one. So put your mouse somewhere, just don't touch it. And when the brightest spot pass you, start. And then the next brightest spot pass you, so I will do it, say start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, stop. Oh, I'm sorry, I may have counted 11. Did I say 9, 10, and stop? When you count 10, you should stop, okay? But here is start, 1, like that. Okay, I think many of us counted either 9 or 11. You have to count exactly 10. If you want, you can try to count 1 first, right? Count 2. So let's say start, 1, 2. So for 2, I got 3.13. So your number should be fairly good for this one, 10 period. I'm not going to give you the correct number. I want you to give it a try. I would say you should do it twice until you get 2 numbers that are close. Okay, we're going to talk about what is close and what is not. Okay, suppose you now get a number for 10 period, divided by 10, you got 1 period, and then you calculate the frequency. No, 14.49 is not close, but look at that number. You have counted 9 periods, I think. That's a very common mistake. Counting 1 is a very common mistake. 14.49. Yeah, that's a very, very typical mistake. You need to, because you need to say start and then 1. Okay? That will, if you count 9 period, it will be a mistake and I will deduct marks. That's a very, very common mistake because some people start, when they say start, they already count 1. That's not right. When you measure the period, you really have to measure full period. Oh, I see. Maybe you can do it this way. Use a side view. Okay, and now you put your, say this, start, 1, 2, 3. Every time a peak passes you, you count 1. The side view may be better. Instead of watching the brightest spot, okay, say like this, 1 pass, 1, 2. Okay, I will redo it. I didn't say the right thing. The first time you want to say start, and then 1, 2, 3. When you say 10, press stop. Well, it seems that so far, I haven't seen a single number that's correct yet. Well, I only see a few close ones. Okay, that's better. Okay, I'll leave it here. I'll leave 1A, and now we are going to do 1B. You still have to struggle with 10 period a little bit. But anyway, when you measure 10 period, everybody now get 4 sig figs. So your frequency will have 4 sig figs. In fact, it's still not that accurate, but we'll find a better way to measure the period with the help of the simulation. Although this one is, this method 1A is not the easiest with the simulation, but in reality, that is how you measure the period and frequency of real waves. With the simulation though, because we have a pause button and we can do slow motions, then we can measure it better. So I'm going to show you how to do it. So reset. And what we are going to do is to pause the so I'm going to pause the screen, say to a special point. The point that I like is when the job is like this. The tip of the water drop is touching the outlet. I think this is a very specific moment, and I will use that to start counting. There's a question asked me to give you a range. I already gave you lots of hints. I mean, your number, all young. The previous the number that you gave me, I told you is 9 period. In fact, it was fairly close. You just missed 1 period. So you just have to count it again. Make sure you count to 10. If you do it right, the period will be the same as the later activities, okay, which we are going to do it now. So this come back to 2B now, 1B. This will be my start. How do I start counting? You grab the timer here and say start. You press the start button. So now the timer has started, but screen is also paused, so the timer is not going. And we are going to measure only 1 period first. So when you measure 1 period, you don't really need a slow motion, but you can try slow motion. So now I'm going to let it go. And I will pause again and keep clicking the step until I bring the screen to exactly the same spot that the tip of the water drop is touching the faucet. See, there I go. It's the same thing, and this number is 1 period. Right? Well, if you don't believe me, we can try it again. You can reset your timer and start it again, and then let it go, but don't let it go. Okay, let it go, and then use the step button to bring your screen to exactly the same spot there and measure it. That's 1 period. This number will be the same every time because you can pause the time. All right, and that's 1B. When you measure 10 period, okay, this is 1 period. You can, oh well, let's restart, okay. So you can say start and then go, count the water drops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, after 9, you should pause so that you don't miss the 10. This is the 10th job. And you want to bring it back to exactly the same spot. And that number will be 10 period. Okay, I'm not going to do it because I don't really want to give you the answer, but you should do it. Bring it back to exactly the same spot. This number will give us the rest of 1B. And I think it's easier than your stopwatch, but if you count 9, you're still going to go wrong. I'm going to put the timer back. Now we are going to do 1C. 1C also measures the period, but this time we are going to use the timer and the side view. Let's take a look. 1C is using the side view, and this is supposed set up simulation times peak. Yeah. Now we are going to measure when the peak arrives at a certain point. That's right. Yeah. When you see the first job, you say start. And when you see the next job, that is 1 complete cycle. So 1 period. The second job give you 1 period. Basically, the 11th job will give you 10 period. That's right. So we are going to measure the period the second way, which is we actually talk about this already. I'm going to use this right edge. So when the peak arrives at the right edge, okay. So when this peak arrives here, that I will say start. And then the next peak will be 1, the next peak will be 2. So I need to bring this one to the edge first. Well, it's a bit, but I think this one is not accurate, but the highest point on the edge will be the peak. And now you start the timer, and now you can start counting, okay? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 10th, this is the 10th peak. You can, step it until this point arrives at the edge, and that will give you the time for 10 period for 1C. And now you divide it by 10 to get 1 period and take inverse to get the frequency. That is method 1C. It's similar to 1B because you are going to use the pause button. Okay, and now for the next exercise, 1D is we're going to see if the amplitude affect the period. So select a different amplitude, select a bigger one, I say, and try any method you like best to measure the period and frequency. So on the worksheet, you select to change your amplitude and then use one of the methods. You should tell me which one you use, 1A or 1B or 1C to measure the period. And then you can find out whether the amplitude affect the period or not. That is question 1D. I will open the worksheet as well so that you can. Yeah, so 1D, you fill in this blank and then give me the period and amplitude. When we compare two numbers, well, we're going to have this thing, whether is 2.5 and 2.6 considered the same or 3.14. Well, let's say for as a rough guideline, because the last digit is the last sig figs will have uncertainty in it, then we can consider 2.5 and 2.6, they agree. And anything, if their last digit is variation is less than 5, we'll say they agree. So 3.14 and 3.18, we can still call them agree because their last digit, they're different by 0.04, which is less than 5. But if their last digit different by more than 5, say this one, 3.12 and 3.18, their last digit varies by 6. We will say they don't agree. They're not the same. Okay. This is because the last sig fig has uncertainty in it. And if two numbers different by uncertainty, we say we can treat them the same. So you should find out a number that will tell you whether the amplitude does or does not affect the period or the frequency. Period and frequency are the same thing, right? If the two waves have the same period, they're going to have the same frequency. And finally, choose the best method you're most confident with and write down the answer for this. We are going to keep 3 sig figs. The period is and the frequency is. All right, so we finish part 1. Let's see my questions. No, there's no more questions. Okay, that's Part one, we are measuring the period and frequency. Part two, we are going to measure the wavelengths. So the activity says, measure the wavelengths, use side view and the ruler. First, we measure peak to peak, and then we measure trough to trough. And then we measure two neighboring middle points. So what you do is, probably that's just best to reset it and switch to side view and start the waves. And then once the waves are built, you just pause, okay? And use this ruler to measure peak to peak. So the first thing is you have to put the starting point at one peak, and then you can check whether it is at the peak. It's probably easier to see it this way. It's good enough. And then drag it horizontally to the next peak. Okay, and that is one wavelength. Okay, to measure trough to trough, you put this to start from the bottom. Well, it's not quite bottom, so put it at the bottom, and then drag the end point to the next bottom to measure the trough to trough. That is one wavelength, a complete, okay, it's peak here, from this peak to next peak, this distance is one wavelength. So that's fairly straightforward. The reading, take the reading from the ruler. To measure middle point to middle point is you have to put this starting point to a midpoint, so it may be there, and drag the end to a midpoint, the nearest midpoint. That is 2A. 2A is fairly straightforward. And now we are going to use the second method, second equation on our worksheet, which is also a fundamental equation. The wave speed is frequency times lambda. You can think about this as a distance over time, right? So peak to peak is peak to peak. V is distance over time. This is a uniform speed. Distance is the wavelength, and the time is one period because we just measured it. You know, when you see a peak, next peak, that is one period. So, but because 1 over the period is frequency, so this equals to f lambda. So frequency times wavelength. And now we already know the frequency from the previous part. So copy down the final conclusion, this number, 3 sig figs. Copy down this number to here, that's the frequency. And copy this number from either this blank and the previous blank, they are the same, right? Peak to peak or trough to trough is the same. Centimeter is fine. And use equation 2. Multiply the 2 to get the wave speed. Oh, it says keep a 5 non-zero digit to start with. So keep lots of digits to start with. This unit is, and we are going to use this unit, which is fine. There's nothing wrong with centimeters per second because the wavelength is in centimeters and the frequency is in hertz. So when you multiply the 2, you're going to get centimeter per second. And now you round it to sig figs. Okay, remember our sig figs rule. If you multiply two numbers together, how many sig figs you should have for the result. And then write down your final answer here. The wave speed of this water wave is something centimeters per second. Okay. Oh. All right, I will leave the actual measurement for you. 2C, let's see what we need to do for 2C. So we've done 2B. 2C is change to a different, change the frequency to minimum, and then measure the new frequency and the new wavelength, and calculate the new wave speed. Has the wave speed changed? Answer the questions on your worksheet. So this one is, you have to change the frequency now. There is a slider here. Change, maybe reset, change the frequency to minimum, and measure this frequency, whatever method you like, from part A, measure this frequency. You can see the frequency is now much lower. Period is longer, the time is longer, and the frequency is lower. Measure this new frequency, measure the wavelength. Okay, you have to pause, like wavelength is now bigger. To measure from here to here, to measure the new wavelength and take the product to find the new wave speed. And after that, you have to answer the question. The new frequency is, you measure it, okay? You can't find it from the simulation. You have to measure it using the method in part A. And to measure the wave speed, use the method in part 2A. This first one is from part 1. Second blank is from part 2A. And then take the product to find the wave speed, round it to 3 sig figs, and see if the wave speed for the other frequency is the wave speed the same with the first one or different. If they're the same, you have shown that the wave speed does not depend on frequency. If they're different, the wave speed will depend on frequency, right? So that's the final conclusion. The wavelength does or does not depend on frequency. Okay. We can also calculate the wave speed, find the wave speed by distance over time directly instead of equation 2. So to do that, what does this say? Measure the wave speed directly by distance over time. We're going to use a pulse to measure how fast the trough reaches the right edge. Start the timer when the trough has formed, and put the start of the ruler at the trough. Show to get accurate readings. Okay. So you can click it to. We're going to measure this distance from for the time for the trough to start from here when it arrives on the right edge. So I'm going to show this to you to measure difference. Okay, all right. So we are going to reset the simulation, and this time we're going to use the bottom one. This one, top one, is the continuous wave. The bottom one is a pulse, just one wave. And now it says you could switch to side view and just let one water, it will have one drop coming out, and then it will be gone like this. So what we are going to do is, does this say anything about amplitude? Yeah. So what you do is make a drop and pause when you see a trough. This is a trough, okay? So pause the screen, bring the ruler, and put the start at the trough. Yeah, it's hard to see. Okay, maybe it's better this way. Okay, here is the start. And now you put this end at here to measure the distance, to measure the total distance. Mine is 8.2, but yours may not be 8.2, okay? So yours may be a different number. And now you we need to time it too. So get the timer and start the timer. Remember to start the timer. Okay, this is started. And now you play and this thing start to travel. When this trough arrives here, you pause again and read the timer. Okay? You can use the step to move the trough to the edge and read this number. And you are going to fill up your worksheet. It takes whatever the total time for the trough to travel a distance of this. The wave speed calculated by distance over time is, again, it will be centimeters per second. That is okay. We are going to use centimeters per second and round it to the correct number of sig figs. And finally, you want to see if the two wave speed, one is the pulse wave, one is the continuous wave, whether they have same or different speed. Okay. So that finished our, we're almost done the first 2 pages. The next one is sound wave. We are going to measure the period, frequency, and the wave speed, wavelength and the wave speed. And I want you to fill in the blank, but give the calculations at the bottom. So the way you do it is you do the other simulation, sound. And well, same method. You want to use the same method to measure the period, calculate the frequency, and then measure the wavelength. The only thing I want you to pay attention is this time is now in milliseconds. This one is still in centimeters. So your unit is centimeter per second, but this one is best if you convert it, because this period is now much slower, much smaller. Your frequency is much higher because milliseconds, right? 10 to the minus 3 seconds. So your period, in fact, is very short. So at the end, I want you to convert. You are going to have a fairly big wave speed if you use centimeters per second. So you should convert that into meter per second. That is the sound wave. The number you get should be a very common sound wave, which is like more than 300 meters per second. Sound travels fairly fast in the air. There is a question of what you should hand in. You should hand in the worksheet. What you should do is to print out this worksheet. If you don't have a printer, you have to copy the entire worksheet. Okay? Ideally, you have a printer and just fill in the blank and hand in this 4-page worksheet. You can you can fill up the worksheet electronically for this lab. You don't have to use a pen. You can use pen or pencil, or write it, type it out. You can type, if you can type into a PDF, that is fine. You don't have to rewrite everything unless you don't have a printer. For most of the question, I don't need to see the calculation, but this one, I want to see a calculation here. Okay, so calculate, say what method you use, whether it's 1A or 1B or 1C, how you measure the period, and what's the period you measured, how you calculate the frequency, and then how you calculate the wave speed, and how you convert that into meter per second. Show that calculations in this space. And next is same thing for the light wave. So for the light wave, you click the light and then start the light. Everything is for the default setting. Don't change frequency and amplitude. Don't change anything. Just use the default setting to measure the period, calculate the frequency, measure the wavelength, and then calculate the wave speed using that frequency times wavelength equals the wave speed. This time, the period will be even shorter. And you're going to use, I think you have to use scientific notation now. Yeah, or you can use this F second. F second is 10 to the minus 15 second. Light is a wave, but this frequency is extremely high. So you're going to use a scientific notation, 10 to the power of 15 something, 10 to the 15th power of hertz to be your unit. It's very, very high. The wavelength, on the other hand, is fairly low. This Nm, N is 10 to the minus 9. So the wavelength is very short, but because the frequency is so high, very high, when you take frequency multiplied by the wavelength, you're still going to get a big number. We are going to use meter per second, but even use meters per second, you still have to use scientific notation because this is the speed of light we are talking about. In our daily life, we feel light. You turn on the light, light, and the entire room, even if it's a big room, will be bright all at the same time. Our feeling is it takes no time for time to travel. But of course, it takes no time for light to travel, but light has a limit, it's, although it's very, very high, but it's still not infinity. That number is high. The wave speed of light is what you're going to put in here. Convert to meter per second, but you have to use a scientific notation. How do you do the wavelength? It's the same thing. You pause and you measure, there's no side view. Side view and top view are the same. So you just measure from the one bright spot, the brightest spot, or you can use darkest spot too, but use the center of this ring to measure. You can measure to the nearest ring, but it's probably better to measure a few of them. 1, 2, 3, 4, say 5 wavelengths. Okay, and then divide it by 5 to get the wavelengths. The same thing, you measure from peak to peak or trough to trough. Except because there are so many here, it's not like water wave. You can measure more than one wavelength, which give you a better number. Wavelengths and the periods are measured. Frequency is calculated. All right. So, and then you'll show you data and calculation here. Part 3 is you have to, I have to tell you how to answer this question. The frequency of the sound wave determines what? And whether sound wave is transverse or longitudinal. So these are some more terms associated with the waves. Here, you have to turn on your speaker. No, speaker. Oh, my speaker is on. To see what frequency changes. And you should turn on the tone, play tone. But somehow I don't hear my sound. Well, you should hear the sound. You should hear a tone when you hear play tone. Maybe I cannot hear the sound as I'm zooming. I don't think so. I don't know. I don't hear a sound, but you should hear a sound. Do you hear a sound when you play tone? And then you can change frequency to see if the tone changes. And then you answer this question. You can see the frequency of the sound wave determines what? When you change frequency, does the speed change? Does amplitude change? Does tone change? So answer that question. To answer the second question, whether the sound wave is transverse or longitudinal. That's a term of waves. What is a transverse wave? Is a water wave is transverse. For the water wave and the side view, what you see is each water molecule goes up and down. Okay, the water here goes up and down, and the wave itself goes to the right, travels to the right. So your wave goes here horizontally, but to particles of this water, particles of the media goes up and down, so perpendicular to the direction of the wave. If the direction of the wave and the direction of the motion of the particles are perpendicular, that means transverse. That's a transverse wave. If they are in the same direction, if water waves go this way and the particles goes also this way, if it goes a lot, that's a peak. If it doesn't go, that's, if it's near equilibrium, that's the midpoint. So you should take a look at the sound wave. When you take the sound wave, you see the waves goes, here is out, and you can turn on particles to see how the supposed to be air molecules, how they move, and you can turn on both. And you will see that they actually move in the same plane. So the air molecules, when we talk, our waves travel, away from me, and the air molecules of air, the particles of air, also goes in that direction of the, from me to the listener. It's in the same direction. That's called longitudinal wave. Here, I just want you to learn the term, know the term, what's a transverse wave, what's a longitudinal wave. The light wave, you can see, so we are not going to do that for light wave. Light wave, the particles does not move because there's no particles. Light can travel in vacuum. So there's no particles of media. And but if you learn more in physics, light is in fact a transverse wave. But what is being, going maximum, minimum, back and forth is an electric magnetic field. But we're not going to answer that question. We're just going to do answer this question for sound wave. For the light wave, we're going to look at what the frequency means. When you change a different frequency, you see what changes. Is the amplitude different? Is the, what is different? Amplitude or color or the speed? Okay, so pick the one. That's very easy to answer this question. Light wave is quite special because the wave speed is constant. Okay, so that, okay, you can, once the frequency is known, you can also calculate. Of course, frequencies and period are related, but generally speaking, the wave speed and the frequency are, no, the wavelength and the frequency are not related. If you look at our worksheet, right? Our worksheet says you can calculate the period from the frequency, but usually you cannot calculate the wavelength unless you know the speed. But for the light, because the speed is always the same, the light wave are special because the light speed of light is constant. So we can also calculate the wavelength. So although the frequency of the light wave determine the color, you know, you can see that in the app, but normally we say the color is related to the wavelength. If you see you know, when you talk about light wave, you usually say the wavelength of the red light is such and such, the wavelength of the violet light is such and such. They usually don't talk about the frequency. It's just these are just learning some terms. Therefore, the wavelength in the vacuum also determines the same thing. Because once wavelength is known, the frequency is known. And now, finally, you're going to see which one has a longer and shorter wavelength. So basically, you change the frequency to change to a different color, and you look at the wavelength, and then you change the red light, and you look at the wavelength to see which one is bigger. If you cannot see, you use the ruler to take a measurement to see which one has longer wavelengths. All right. Okay, so that finished our part 3. Part 4 is, so we're going to do part 4 now. Is I think part 4 is maybe a bit harder. So let's give it a try. We are going to close this simulation, and part 4 use a different simulation. So right click on this one and open a new tab. We are going to learn another way to measure the wave speed. This is measure the wave speed by standing waves. So you're going to have this one, and you can create, the waves are like this. It goes, these are waves on the string. You can see the particles moving quite well. And once it hit the other end, which is fixed, the wave got reflected. So what we are going to do is, yeah, first we measure the wave speed by distance over time. Okay, so we are going to use a pulse and set the amplitude to very high and pulse to very low. And you can send a pulse and you can see it travel back and forth. We're going to use this distance over time to measure the wave speed. But because it dies down so quickly, we're going to put the damping to 0. Leave the tension to high always, okay? So now you send it out, it's going to go back and forth forever. And then making it really easy for us to measure the distance over time. The lab says we want to measure 5 times, 10 times on the string. So we want it to travel at, pick a starting point. Oh, I want to do it maximum amplitude, narrowest, most narrow width, and no damping. And send out one. So the way we do it is to pause, find a special, Let me pause. Oh, I clicked the wrong button again. Oh yeah, the way to restart is to hit this button, restart. This will keep all your settings. So restart is better than this button. And now you send out one and you want to pause. You want to find a good spot to start counting. What will be a good spot to start counting? Okay, this is a good spot to start counting. This green dot is at the top. See? And now I will turn the slow motion on to let this go back and forth 5 times. So right now it travels about one length of the string. And when it come back, now it travels 2 times the string. That's 1 back and forth. So the distance is 2 times the length of the string, and the time is, we haven't started counting yet, okay? So we can start counting at this time. Bring the timer, start the timer, and now we can start counting. This is to find out the time. Well, it's going quite slow, but you know, maybe I should go back to normal. That's 1 back and forth, and 2 back and forth, 3 back and forth, 4, and when it's about to be 5, you want to, use this to bring it back to exactly the same spot, okay? And that is 5 times back and forth. When you pause at the same spot, you read from your timer. Again, I didn't want you to give you the answer, so you have to do it yourself. You can use a slow motion if you want. The whole idea is you bring this pause back to exactly the same spot after it travels back and forth 5 times. That will be the total time. The total distance, you need a ruler to measure from this point, which is the start, it's at 0, to this point, okay? Measure it at here. Take a reading, that is the length of the string. And you want to multiply this 10 times will be the distance, total distance. And the unit is centimeters. So back to our worksheet. It takes total time for the pause to go back and forth, which is 10 times the length on the string. The length of the string is this, multiplied by 10 will give you the total distance. The total distance over total time is the wave speed. And keep the answer, it's still in centimeters per second, but I want you to keep the right number, correct number of sig figs. Sig figs. Okay, so measuring using distance over time is very straightforward for this app as well. But now we are going to use a different method, sending waves, to find out the wave speed. The equation we are using here is also frequency times wavelength. Frequency is now, if we use oscillate and let it go, okay, so start. Frequency is given here, 1.50, but what is the wavelength? How are you going to measure wavelengths here? For this frequency, there's really, you almost cannot measure wavelengths, but there is some special, at some special frequencies, this wave pattern will be stable. And when the wave pattern is stable, we call that a standing wave. For standing waves, we can find out the wavelengths. So first, let's try to set it up manually. what you do is you can move one end at certain frequencies to build up a stable oscillation pattern. And you have to, you can play it yourself. I don't want slow motion now. It has to be normal, otherwise it's too hard. Basically, when the wave, when this wave arrives at the other end, you're going to move it down. So up, down, up, down. And after a few tries, you can see you can build a relatively stable wave pattern. And that is standing wave. We're going to use this to figure out the frequency and then put that frequency into oscillation mode. Because we want to use oscillation, our hands cannot move as well as that oscillator. So this is the first part, is to we want to find out the period and the frequency and estimate this frequency. This frequency is called fundamental frequency. That's the lowest standing wave, lowest frequency. That's the standing wave with the lowest frequency. So how do you find the period? Is we can observe one point, say pause, and say we aim at, we aim at this green dot. So the green dot is touching this line, and you start the timer, and now you count 5 period. So now it's going to, let it play. And when you come back here, this is about 1 period, 2 period, 3, 4. Okay, and you want the 5 to be exact. So now this is 5. See the green dot come back to exactly the spot. This is the 5 period, right? So take 5 period divided by 5 and divided by 5 and take the inverse to get the frequency. The number you get is roughly like 0.41 or 0.44. So you finished this part, okay? And now we are going to go to oscillate, and change this to that 0.14 or 0.41 or 0.44. Say 0.41. And you start. Oh, no. You want to move the change it to very small amplitude. I think our lab write-up says we're already at 4C. Our lab write-up says 0.05 centimeters. So 0.05 centimeters. Okay, and now start. You see it has a very small amplitude to start with, but because this is the right frequency, each time it oscillates, it gives more energy to the wave, so the amplitude will build up. You put the reference line at a distance, and you will see it's going to get bigger and bigger. It will eventually get to reference line. See, it's still getting bigger. Yeah, this reference line will show you it's actually, this amplitude is getting bigger. See now how beautiful the wave is? Because this is much better than my hand shaking the wave. Anyway, once we are happy with this beautiful standing wave, what we are going to do now is use the settings shown in the picture to try to set up with oscillate mode. It asks you to try different frequency, but we have I basically gave that to you. And now you can figure out the wavelengths and the frequency. The frequency is already given. Frequency is here, right here. You can read it. Wavelengths is, you see, this is like half a wave, which is exactly correct. It's not a full wave including a maximum and the minimum. So you're going to use the ruler to measure this from this distance to that distance. That is half a wavelength. And use that to calculate the full wavelength. We're using this one. I found the frequency to build the maximum amplitude for is this much. And the node to node, these are called a node. This fixed point is a node, okay? You can calculate the wavelengths. So you know half of the wavelengths, and you need to calculate the total wavelengths. From the wavelengths and the frequency, you calculate the wave speed. That's 4C. 4D is same as 4C, except we are using the next standing wave. The next standing wave is like this. I'm not going to do, I'm just going to show you what it is, okay? So I'm going to set the damping to 0. Second wave, the second standing wave will look like this. I know you're going to use the oscillate to build it up, but the general shape is looks like this. And this is a whole wave. So this is a node, that is a node, that is a node. This is half wavelength. This is also half wavelength. So you should figure out what the whole wavelength is. I'm not going to finish this. You're supposed to figure out what the frequency should be and use the oscillate to build up this standing wave. And then the same thing, same as 4C, to find out that this new frequency, what is the wavelength? Remember this time, okay, this time from here to here is one wavelength. So figure out the wavelength and then calculate the wave speed. All right, so that is everything that's required for today's lab. Part 5, the last part, is optional. This one, we can look at the video together, but it's optional. If you do it, you get a bonus mark. We can look at this video on the YouTube. This one is the real standing waves on the string. What? That's that. I don't understand why I don't have song today. It's okay. I'll just play it. When you watch it at home, there will be a song. This is like 3 minutes. I can talk. That's this yellow shaft connected to a speaker can go back and forth to make this string vibrate. And this thing is called a function generator that have like the oscillator in the simulation. This will make the yellow shaft go back and forth. They're connected, and this will display the frequency. Okay, I'm going to show you. When I increase the frequency, see the this string start to vibrate, and at the right frequency, it's going to create that first standing wave. It's a fundamental frequency. You see, it's getting bigger. And I'm doing some fine tuning. So finally, see, it has this, oh, that's the first standing wave where the entire length is half a wavelength. Yeah, and then I have to measure this wavelength, which is fairly long, more than a meter, almost 2 meters, but not quite. So I use a meter stick to measure the length of the string. You can watch that yourself if you want to do the optional part. This is real waves on the string. The same thing, you read the frequency, you calculate the wavelength from the length of the string, and take frequency times wavelength to get the wave speed. There is also one way to calculate the reference wave speed, and it shows you the method here. So you can compare the measured wave speed with the reference wave speed. But this part is optional. Part 5 is optional.